Hi, welcome everyone for this session on deploying Spring Boot microservice to the cloud. We're going to use today three tools that I love. We are going to use Spring Boot. I'm an all-time Spring Boot user. I have even worked at Spring Source like 10 years ago. We are going to use JHipster, which is a code generator for Spring Boot, and I am the author and lead developer of JHipster. And we are going to develop everything, to deploy everything to Azure Spring Cloud, which is a service I am working on Microsoft Azure, because I work at Microsoft now. We are going to see how those three tools fit together in order to make you more productive, more efficient as a developer, but also as somebody who pushes microservices to production and want to scale them and make them run beautifully. So let's get started. And first, let's do a small introduction to JHipster. So JHipster is an open source code generator. It is available on jhipster.tech. It is fully free and open source. We've got a lot of users. So just last month we had more than 150,000 installations of JHipster. We've got more than 15,000 GitHub stars, and we've got more than 500 contributors. So we've got a lot of people using it, but also a lot of people contributing. If you want to use it, well, you're most welcome. It is open source, so it is there for you. But also, if you want to contribute, well, you are also very, very welcome. We would be happy to have more contributors, as always. So don't hesitate to have a look at the product and join us if you are interested. Then let's go to Azure right now, because what we are going to do is push microservices to production, and for that we need some cluster. So I am going to create, first of all, what we call on Azure a resource group. So a resource group is just a logical grouping of resources. I'm going to call it Spring Live. This is where our deployments will take place. I'm going to put it in West Europe because this is where I live. Okay, let's go there. So it is empty, I just created it. And inside this resource group, I'm going to create two resources. First of all, I'm going to create my Spring cluster. So using this new service called Azure Spring Cloud, we will use it just afterwards. It takes some time to get created, a few minutes. So I'm doing it right now, so we don't have to wait afterwards. So I'm taking all the default options everywhere, of course. So first thing we wanted was our cluster, the Spring Cloud cluster, and now I wanted also to have a database. On Microsoft Azure, we of course support a lot of different databases, including SQL Server, Cosmos DB, which is a globally distributed database. For this demo, I'm going to use MySQL because I'm guessing this is what a lot of people are using. So I'm creating one. I'm also calling it Spring Live, like everything else. I will put it in the same location as everything else, which is West Europe, if I can find it. West Europe, here it is. My username will be Spring Live. My password will not be secret. You will see that in a moment. 2, 3. And I'm also going to create this. Okay, so my MySQL database is getting created. My Azure cluster is getting created. Let's not wait for those to be created, and let's work on our application. So I want to create a Spring Boot application. I want to do that using JHipster. I've got basically two options. The first one is to do that manually. I can just run the JHipster command line, JHipster. And well, this is going to ask me questions on the application I want to use. As you can see, JHipster is always trying to help you. I'm running that in my home folder. That's not a good idea. Well, I know, I'm not going to run it. That's the first option to run JHipster. Just run the command line. Other option that we have is using what we call JHipster Online. So JHipster Online is a web application which is doing exactly the same thing as the command line application. Well, it is a simplified version to be fully correct. And that simplified version is going to be what we use for this demo because it's easier and it's more graphical. So for a demo, it's a little bit better. So let's create my app. I want to create it in my GitHub organization. I'm going to call it test because I don't have any good names at the moment. My application can be of several types. So by default, JHipster will generate monolithic applications. So applications which have both a backend with Spring Boot and a front end, which can either be with Angular, React, or Vue.js. In our case here, we are going to use a microservice. So the main difference with a microservice is that it doesn't have a front end. So you don't have Angular, React, or Vue. Also, it's going to be able to connect to some Spring Cloud Discovery server or Spring Cloud config server, but we will see that a little bit afterwards. So it's going to ask me a few questions like my package name, my default port, what do I want to use to scale my app. So the JHipster registry is at the same time a Eureka server and a Spring Cloud server. So this is what most people would use to scale their microservices. That's also what we are going to use on Azure Spring Cloud, but this is fully integrated in Azure Spring Cloud. So in fact, we don't need here to do anything. We just I'm removing it just to simplify stuff. We don't need that at all here for production. When I will be developing, you will see it will make some little warnings, but it's not very important for developing. And for production, we don't need it. So let's remove it. It's asking me also my security options. Here also we've got like two main options. The first one is JSON Web Token, which is very easy, very simple to use, and which is for this very reason the default option. If you want something which is more secured, which is honestly better in production, you need to have an external server with OpenID Connect. The option 2 and 3 are basically the same ones. Most people will use this option. So here we've got OpenID Connect authentication. That works with Keycloak, with Okta, also with Azure Active Directory. This is clearly what I would recommend in production. Here, as we've got some simple needs for a demo, we're going to stick to JSON Web Token because it's much easier. After that, we've got some questions about the databases that we want to use. So JHipster supports a lot of databases, like most SQL databases, also MongoDB, Cassandra, Couchbase, Neo4j. You can also choose no database if you don't want, if you don't need to have access to any data. Here, as you remember, we created a MySQL database, so we will stick here to MySQL. It's in fact, it's the default with JHipster, so we will have MySQL in production, and we will have H2, which is an embedded database. We will have H2 in development. Again, those options are here to make your life simpler. You will see that everything works out of the box with JHipster, but if you want to do better, we will provide you those options and the documentation to help you do better. But this is for more advanced users. What we first want as a rule is that everything works easily and smoothly for people who don't know anything about JHipster. So I've selected MySQL. As I'm using Spring Boot and Hibernate, I'm going to be able to use some Hibernate second level cache and also some Spring Cache. Those options are really interesting for production. Then for this current demo, they are going to cause some questioning. First of all, our most popular option is EHCache, which is a very, very good cache, but which only works with a single node. It cannot scale dynamically on multiple nodes. And that's what we would like to do with our microservice. So EHCache as well as Caffeine will not be good options for our scalability needs. Then we've got Hazelcast and Infinispan, which can scale automatically. Those are good, but for those you need some mechanism for them to discover the nodes. Those work very well with JHipster because we've got some specific configuration for that, but I find it a little bit advanced for a demo. So I'm also not going to use them. And then I would say the easiest options would be Memcached or more importantly Redis, because we've got Redis support on Azure. And if you select those, you just point to your cache server, and then all your microservices can scale using that cache server. So probably the last option, Redis, would be the best one in production with Azure if you want a cache. I'm going to say no, just to remove all those questions. Of course, it's not the best option for scaling. I'm going to keep the other options by default, so I'm going to build with Maven. I'm not going to use advanced stuff like Elasticsearch or Kafka. We've got tons of options with JHipster, and it goes way beyond what we can do in 1 hour. And for testing, JHipster will provide you with a full JUnit test suite to validate that what we have generated is correct. But you can also add, for example, performance test with Gatling, which is what I'm going to select right now. Performance testing is very important for microservices, so it's probably an option that you will want to use. So now that I have selected all those options, I am going to generate my app on GitHub. I could have also downloaded it as a zip file. In that case, I would not have needed to have a GitHub account. JHipster generates the app, pushes it to a GitHub repository where I can just, git clone it. So I'm taking the URL. I'm going to open it with IntelliJ IDE. And what JHipster does is that it generates by default, so of course your Spring Boot application, but also a lot of configuration files and also some documentation. So you can see that by default my README file has been opened, and that it gives me access to the documentation of the version of JHipster I have used. It tells me how to start developing using the Maven wrapper. So Maven is integrated inside my app, so I don't even need to install it. It's telling me how to build for production and so on and so on. And everything gets automatically configured in my IDE because JHipster has generated some configuration files like a gitignore file here, or also here some interesting configuration files. Prettier is a solution to reformat all your source code, so everything is perfectly formatted. This is very popular in the JavaScript and TypeScript world, and so for JHipster we use that a lot for the front end and for also Markdown files, YAML files, and so on. We wanted to have this also for Java files, and we wanted so badly that the JHipster team has coded the Prettier implementation for Java. So now you've got also Prettier for Java, which is arriving in your IDE thanks to JHipster. So here I've got my perfectly formatted Java source code. So everything is configured for me. You can see that my IDE recognized my project as a Maven project. And it even recognized my main file as a Spring Boot file, so I can just click on it and my app will start up. Once again, we're using an embedded database, so I didn't need to start in a database. It's just going to start automatically and everything will work. So my app is running. If I click here, once again, everything works by default, and I've got a web page here to help me and tell me, give me some information and give me some pointers if I need to have any help. Once again, it works by default, and we help you as much as we can when you have any kind of issue. So my microservice is running. Let's have a look at what it looks like inside. So here we've got a very classical Spring Boot application. If I click on my main file, we can see that it's a Spring Boot app at a Spring Boot application here. It has got a very common hierarchy of directories. I've got here my Spring Boot configuration, which is neatly separated into some small files. And I've got some directories which are very common for Spring Boot developers. I've got here a domain directory for my domain model. I've got a repository here directory, I've got a service layer, and I've got a web layer for my REST endpoints. Those are pretty empty for a very good reason. JHipster by default generates an empty project. It's not totally empty. You've got some configuration here for Spring Boot, some security configuration here. So we selected JSON Web Token, it's configured here. And it's also configured like some very common errors. So everything is working fine out of the box, but you don't have too much. Let's just have a look at the errors, because that's what we last saw. If I do, for example, a curl request on my app, so it's running on port 8081. Let's say API test. So this is, so we secured everything with JSON Web Token, so I will not be secured. And as we can see, JHipster gives me here a nice JSON formatted message telling me I'm unauthorized. This is my status code. I also add the correct status code in my HTTP header. And it's giving me a documentation of what my issue is. And when I'm going to use that in my own project, it's telling me, oh, I can customize this page to help me. So really everything is done to have a good, secured, documented configuration, but you have no business code at the moment. Now let's have a look at how we can improve that, and let's add some business code. Some code first, some simple code first, sorry. So first of all, what I wanted to show you is the hot reload of our application. So we are using the hot reload features from Spring Boot. So for example, if I go here to my main application, and if I add some code here, if I say hot reload is great, what I just need to do here is compile my file. So my IDE is going to compile it. And then behind the scene here, what is happening is that Spring Boot is restarting my app. It has already restarted it in 2 seconds. And you can see that hot reload is great. So all I need to do now is just compile my file, and I've got hot reload working all the time, which is really awesome to get started. So if I want to work on my generated app, I can just code it like that. You can see everything is configured, including hot reload. I've also got a full set of tests here with JUnit. So I can just click here to run all my tests. And of course, while working on my app, those tests should continue to be green all the time. If you remember, I selected Gatling to have some performance tests. We will get to that a little bit later, but this is also where we'll generate our performance test just afterwards. So at the moment, I have no real business code. My app is running, it is fully configured. Let's add some code, so I can either code it like we just saw, or I can use what we call a sub-generator in JHipster. So JHipster is a generator, so it generates an app. And then we've got sub-generators. So those are components that are going to improve what has been generated by JHipster. We've got more than 100 of them, so there are a lot of them. I am going to show you the most useful and common one, and that should give you a good example of what we can give you. So I'm going here to JHipster Online again. In JHipster Online, we've got a few sub-generators that are available as a web application. And I'm going to use the design entities screen, and I'm going to go here to the online shop. So my online shop, as you can see, looks like a kind of UML diagram. It is being coded using the JHipster domain language, which you can see on the left. I already typed JHipster forever. I can put I love JHipster now, for example. So you can see that this is a property in my entity. This property is of type string, and it is required. This is being shown here in my UML-like diagram. What JHipster will do is that it will use that domain language to generate your database configuration. So it works with SQL database, but also MongoDB, Cassandra, and Neo4j. And it will also use that configuration to generate your Java code, your source code, and your test code. And if you do monoliths, it will also generate the JavaScript code on top of that, all your front end. I'm going to save this configuration, and I'm going to tell JHipster Online to apply this configuration to the application I have just generated. So I click on apply, and this is going to add a pull request to my repository with the entities I have selected, so category, product, customer, address, wishlist. And once this pull request is here, I can simply merge it. Let's merge it So that is now generated in my GitHub configuration. Now, if I go back to my IntelliJ ID, for example, here you can see that my domain model is, let's say empty. I'm going to do git pull and have this new configuration arriving. So just by doing this, everything that I have configured with the JHipster domain language just appeared here in my domain layer, repository layer, or REST endpoints. Everything is here. I'm going to rebuild everything. So once again, hot reload will kick off, and my app will automatically reload with this new configuration. Sorry, where is it? It's here. It's already done. So everything has been reloaded, and my app is now running with that new data. With that new configuration, including with the new data. You can see that here we are using Liquibase. So Liquibase is a system to update your database on the fly. And what JHipster did is that it configured Liquibase in order to update my database schema with those new entities. And it also generated some fake data that I'm going to use in development. So if I open this up, for example, this is a CSV file, I can open it very easily with Excel or whatever I want to open CSV files. And I can change that code and that sample data very easily. Let's have a look at all this. So my app is already restarted. It's still running. Let's go back to the app. It's still running on port 8081. Now what I would like to do is access one of those REST endpoints. By the way, they're all exposed as Swagger endpoints if you want to use Swagger. I'm not going to need that right now because it's very easy. I'm going to have a look at the category, for example. So it's on /API/categories. So I'm going to run the query I just did before. So curl. Oh, sorry. 0.18081 API/categories. So this is again going to fail because I am not authenticated. As I don't want to lose time configuring the JWT token for just a simple demo, I am going to remove the security. So I just go to security configuration, and I'm going to tell, okay, all requests to /API are going to be allowed for everybody. Of course, you should not do that in production. You should get your JSON token. But for doing my microservice here, it's going to take a couple of minutes, and I don't want to lose time. So now if I do curl again, now I've got my data. So as you can see, we've got sample data coming from the database. So JHipster generated for me my domain model, my repositories, my REST endpoints, and also some fake data from my database, so I can have something, let's say, useful from the start. I can already work on everything. If we have a look at the test, so once again, JHipster generated test for everything. So for example, it generated test for our customer. So you remember we had some tests running. Well, now I can run them again, and I will have more tests than before. You can see that now you've got all those new tests arriving. And also JHipster generated some performance tests with Gatling. So if we have a look here at the Gatling test for categories, well, we've got some Scala code for that to test the performance of this REST endpoint. So we've got a full suite of tests, both for unit testing and performance testing, which is very useful in production, well, when you want to deploy your app to production. I got everything working fine. Now what I would like to do is deploy everything to Microsoft Azure using Azure Spring Cloud. So first of all, let's go back to Azure and have a look at what we have generated. So we've got here an Azure Spring Cloud cluster, and here we've got a MySQL database. I'm first going to the database. I want to have access to the connection security. So by default, databases on Microsoft Azure are secured, which is very good. I would like my cluster to access it. So I'm going to open up my firewall here. I'm also going to add my current IP address to the firewall. So if I have any issue, I can access my database and have a look at it. Hopefully, we will not have to do that during that demo. You've got more secured options on Azure using what we call VNet. So a VNet would be a private network which is only available for your database and your Azure cluster, so that people from the external world could not access it at all. So that would be even better security. But that's enough for our demo here. What I just wanted to have here is my connection string. I'm just going to copy paste my my URL. Let's go back to my app here. So JHipster generated a few Spring Boot configuration. We can see we've got a base configuration here, and we've got a few profiles. We've got the dev profile for doing development. TLS is also for doing development, but using SSL, so it's a little bit more advanced. But it's useful if you want to test HTTP2 and SSL on your app. And here we've got a production configuration. This is where I want to configure my data source. I'm going here to Spring Data Source URL. I'm going to use my my URL here. I'm going to force the usage of SSL. This is something you should do anyway in your apps. It was set to false by default because we are connecting to localhost, and probably you don't have an SSL certificate for that. But in production, like we are, we should go to SSL. My username is going to be springlive@springlive, and my password, I said you would see it. Here it is. Of course, this is not a very good configuration. We're going to do better just afterwards. But this is just to show you basically how JHipster works, and then we will see how we can do better with Azure Spring Cloud. So here I've got my data source, which is configured in production. Now let's go to my Azure Spring Cloud cluster. So Azure Spring Cloud is a new service which is jointly developed by Pivotal, VMware now, and Microsoft Azure. So both companies work together and support it together, and that's why you've got some Pivotal components running inside Azure now. It is based on Azure Kubernetes service, but you don't see Kubernetes at all. You need to see that as a platform as a service. So everything is managed for you. You just push your apps, and they are going to be managed, scaled for you. So let's have a look at a few options first before we deploy to production. So first of all, here, if we go to settings, if we go to apps, this is where you can create your applications. I'm going to create one. This is the one we are going to deploy. I will call it test. It's going to run on Java 11. It's going to have like 2 CPU, so it starts faster. If I click on create, so my app is going to get created. We'll just come back here a little bit afterwards once it's created. Second menu item here is a config server. So config server is what is being used by microservices to get the configuration from. It is very important to use that if you use Spring Cloud. This will prevent you from doing what I just did before. Here I coded some configuration in my project, so this will be pushed to my Git repository, and everybody will have access to my password. So that's indeed a very, very, very bad idea, and you should not do that at all. So for this, Azure Spring Cloud provides you a few options. The first one is using an external Spring Cloud config server. So the Spring Cloud config server is going to be connected to a Git repository. I'm going to use one of mine. So this one is public, so same issue as before. You should not use a public one, just for the demo. Let's take this Git repository. Let's configure it. paste. You should configure it using HTTP basic or SSH, of course, and not keep it public. So what's going to happen here? I'm going to apply this configuration, and that means that all my microservices will get the configuration that is here. And of course, here you can have different configurations, you can have different profiles. It's a very simple configuration, which is just pushing you some message, which tells you that it's correctly configured, but that's a good message when you want to test that everything is working fine. And for this, you need an application.message key into your app. I have not coded it yet, so let's go to my application. If we go to configuration, application properties, so JHipster has generated for you a default properties configuration here. And so the prefix is application, and we wanted to have a message property. So I'm going to code it here, string message, and generate the getters and setters. And so as soon as my app will start, the configuration property here will be set inside my variable here. And I know it will work. Well, yes, by default with JHipster, and well, I think it's a default also with Spring Cloud, if some property key is missing, it will not start up. It will fail at startup. So we don't even need to check if the message is correct. If it starts up, it means that it's correct. Otherwise, it will just fail from the start. So let's go back here. We saw the applications. We saw the configuration server. We've got a third very important concept here. We are going to have a Spring Cloud discovery server, which is based on Eureka. You don't have it as a menu item because you don't have access to it. It is also fully secured. It is clustered. It is managed, updated, patched, and so on by Microsoft Azure. And you are also consuming it. You can see it working here. Up 1 and down 0. This is so our Spring Cloud discovery server, which tells you that your app is up. If we click here, we've got a sample app by default. Let's have a look at this app. So by default, it's secured here with a token. I can also make it public. It's going to be easier for our test. Of course, your microservices will probably not be public by default. So if I go there, we can have here our sample application running. Okay. So we've got our sample application running. We've got our real application, which is ready to get pushed to production. Well, let's do this. There are several ways to push our application to production. We are going to use a new subgenerator from JHipster. It is called JHipster Azure Spring Cloud. And what JHipster Azure Spring Cloud is going to do, it's going to ask you a few questions to deploy your application to production. I just wanted to check again. So my app, my cluster name and my resource group are all called Spring Live, because it's going to ask me. Oh, sorry, I put some default resource group. So if you want to automate everything, you can put some default resource groups and some default cluster name here in some variables. That's what I'm using to ease my configuration, but you should not, you should do that once you are confident with it, but otherwise it's probably not a good thing. So it's asking me now my resource group. It just checked if it was ready, and now it's ready because I configured the correct one. It's asking me for my cluster name, the name of my app, which is by default was the current name of my app, so that's test. And now I've got two options. I can either build my app locally, so I build it with Maven and I deploy it using the AZ CLI command line, or I can use GitHub Actions. So that would configure a workflow inside GitHub Actions, which is, if you don't know about it, it's a continuous integration and development platform and deployment platform for your GitHub repositories. What is good with GitHub Actions is that it would allow you to just git push your app to production. You would just as soon as you do git push on your repository, then GitHub Actions would kick off a workflow, and that workflow would be able to build and deploy your application like what I'm going to do here locally. It's the same thing, but it's in the cloud. It's probably a better option if you have, well, for your developers, because in that case, they don't need to know anything about JHipster or Azure or anything of what we just saw here. Just git push, and it's going to work out of the box for them. So it's a very good solution. Then so JHipster is going to modify a few files to allow deployment. I'm going to say yes here, and we're going to have a look at those files. Because JHipster is going to take some time to build my app, to test it, and to deploy it. So now we've got some time to have a look at those files. So what JHipster did is that it modified our pom.xml file. If we go at the bottom of the file, we can see that JHipster added a new Maven profile. So this is for build time, and this Maven profile is adding a few dependencies. Let's have a look at the important ones. This one is specific to Azure Spring Cloud. It's the only specific dependency on Azure Spring Cloud, and it is used to get the SSH keys to connect to the Spring Cloud config server and the Spring Cloud discovery servers that we use in production. So it's a very small package, but it's very important. And then we've got some, I would say, classical and standard Spring Boot starters. One for using the config server, one for using the Eureka server, and one for using Zipkin in order to have distributed tracing of our application. So that was for build time. And for runtime, JHipster also generated a specific Spring Boot configuration with a specific profile, which is called also Azure. While this file is mostly empty, it's not very important to have a look at that. It's like for the debug logs and so on. And this is also, well, this is what you will be able to customize once you're in production on Azure. JHipster has modified all those files. It has generated, packaged the app again, and now it is pushing it to production. We had already configured the app here. Let's go there, and let's have a look at my app. So we can already see we've got one up and one down. So you remember we had here our sample app running. This is going to be replaced by the microservice we just developed. And that's why it's getting done, and we've got one up, we've got the other one arriving, and it's going to replace the microservice that we have by default. Let's have a look at the logs. So here I'm going to use the AZ CLI command line. So if you do AZ Spring Cloud app logs, you're going to have the logs for a specific application. So mine is called test. I'm going to have two instances as we just saw. I'm going to take the second one because I know it's my new instance. And I'm going to follow the logs to see my app getting deployed to production. We can see it's already deployed. Oh yes, it's already deployed here also. So everything is working fine, at least so it seems. It connected to our database, and it also connected to the Spring Cloud config server. We can see here also it connected to Eureka. So we got the config server, the discovery server, and the database, which were correctly configured without doing anything. And my app now should be running, so up 1 and down 0. And if I go to my app here, we've got my JHipster homepage. Now let's have a look at the data. So you remember I did some curl request earlier, and it was on what did I did it? That's a good question. Probably on the categories. Anyway, you remember I had some sample data, and that was only for development. In production, we've got no sample data, so this is going to give me an empty array. So it's an empty array, but that empty array comes from the production MySQL database, which is empty all the way through Spring Boot and to my my console here. So this shows that everything works fine. So we have deployed our app to production. Let's have a look at all this and what we can do to improve what we have just done. So Let's click on our app and let's have a look at the menu items here. So first of all, we can scale our app here both horizontally and vertically. So we can add more CPU, we can add more memory, but we can also add more instances. And as you remember, I didn't have any cache, so this is going to scale well because I don't have cache synchronization issues. But then, of course, this is probably going to eat my database quite badly. So I'm going to 4 instances of my microservice. So yeah, I'm scaling it quite heavily. You remember I had some issues about configuring my database. I put my configuration here in my Git repository. We said it was not a good idea, and indeed it is not. You've got other options to configure that in Azure, which are a lot better. We have seen you could configure that in your Spring Cloud config server, but you can also here have some very simple environment variables that you can use. So you can just put it here as key value pairs. That would work also very well. And an option which might even be easier is service bindings. So this is going to configure automatically Spring Boot with some available services. Let's have a look. I'll call it test again. Here it's going to work with my SQL. It's going to scan my resource group to see what I have available here. So it's finding my database, including my database name, which was called test, the name of my app. I need to add my username and password, and that would automatically configure my database. So that's another option which might be easier to configure your service bindings on Azure Spring Cloud. Let's have a look at my app. As you can see, I've still got 1 running and 3 done. I selected 4 instances. The 3 other ones are arriving, we just need to wait a little bit, and they will be there very soon. Let's have a look at the other menu items here. If you don't want any downtime, we allow you to do blue-green deployment. So basically, when you do a deployment, instead of just replacing the existing app, which is what I'm doing right now and which might not be perfect in production, you can deploy in a stage environment that nobody sees, and then you can swap production and test environments on the fly, so you would have like no downtime at all. So that's what we call blue-green deployment, and that's probably a better solution to deploy to production than what I just did, which is just replacing the app. We've got some specific test keys when we went to our application. Let's go here to our app. I put it publicly here, but an application, of course, a microservice should not be public. You should have like a gateway to expose it. And so you should hide your microservice from the outside world. And you've got here some specific keys to access it if you need to test. Those can be fully disabled if you don't want them at all. So by default, your microservices are secured with a key. You should not make them public, and you can disable everything if you don't like that. Then, oh yes, something very important here. As always with Azure, you can automate everything. So this is called ARM templates. So ARM templates are the way on Microsoft Azure to automate what you do. As you might understand, what I did just before using either the portal or the CLI is very error prone. It's going to also take you a lot of time, and it's going to be hard to reproduce my setup. So if you want to automate everything, well, we've got ARM templates here to automate all that. A lot of people like to use a competing solution called HashiCorp Terraform. This is not ready yet, but you will very soon have HashiCorp Terraform on Azure Spring Cloud also. So we've got also you covered if you want to automate everything, and you should automate everything. Last but not least, monitoring. We have launched our microservice. Everything went well, but it doesn't work well all the time, of course. We saw we could stream our logs. That's what I did a little bit earlier here. a good solution to debug when you are developing, but in production you want something better than that. Here we've got quite a lot of monitoring options. The first one, of course, is just here logs. You have access to your logs with a SQL-like syntax, so you can find your logs and query them and know what happens. It takes a few minutes to gather the logs, so I'm not going to do this. I'm not even sure they have already appeared yet. It's not very important for that demo. I guess everybody understands that we have access to the logs and we can query them. Second screen, which is more interesting probably for Spring Boot users, is we've got a metrics screen. So here we've got full access to our metrics from the JVM to Spring Boot to everything. And so you can do like, for example, here, a nice graph of your JVM memory, and you can set alerts. So those alerts could be just like memory is too high, you should do something. But you can also use them to scale your app automatically, which is probably what you will want to do. So logging and monitoring are the two screens that I guess most people will be familiar with. Then we've got a last screen, which is which can be more which is more advanced. You can have a full application map of your microservices. It doesn't make much sense because we've got only one microservice, but as we have instrumented our microservices using a Zipkin, just by doing this in our Maven profile, well, our application is going to be fully monitored by something called Azure Monitor, and it will be able to know the performance of the HTTP requests that go through your microservices. And so you will be able to have a graphical view of all your microservices when you have several of them, of course. And you will have access to performance metrics and errors, and you will be able to drill down and see them. I just wanted to go back to my apps because we scaled them to 4. As you can see, now we are 4, and so now we've got 4 instances of our microservice running in production. And of course, it still works. If I do my curl request, it's still going to work. Okay, so we've went from zero, from nothing in our GitHub repository to deploying a full Spring Boot application to production and scaling it and monitoring it and configuring it using the config server and using the discovery server. So that was quite a complete session today. If you want to know more about JHipster and our support for microservice, I recommend you, of course, to go to our webpage. We've got full documentation. If you go here to microservices, you can go to overview and have a lot of information on what we support. If you want to know better what we allow you to do to production with Azure, we've got here also a specific web page documentation on deploying to Microsoft Azure. Of course, if you want to know more about Azure Spring Cloud, well, you should go to the Microsoft Azure web page. Thanks a lot, and I hope you have enjoyed this. Goodbye.